Welcome to Homework Lib.
So in this case, what we want to find is what is the minimum speed in meters per second and miles per hour that Damien Walter needs to achieve in order to make the loop over here. So what we want to use in order to derive this is the sum of the forces that are going to appear at the very top of our movement. So over here, the normal force is going to be looking downwards as well as the force of gravity, mg. But remember that Damien is making a circular motion with a certain velocity, so that means that we're going to have as well a centripetal force, which is equal to mv squared over the radius. So we can say that that centripetal force that is going outwards of the circle needs to cancel the normal and the mg forces that we have over here. So what is going to happen is that the equilibrium forces is going to tell us that the sum of forces needs to be equal to 0. We're going to have, let me correct this a little bit, I was going to skip a step, but since the sum of forces need to be equal to 0 in order to be in equilibrium in this case, that would be the point in which he would lose contact with the surface. What we're going to have is centrifugal force needs to minus n minus mg needs to be equal to 0. From here, we know that centrifugal force is equal to m plus mg, which gives mv squared over radius is equal to the normal force plus mg. Now, we have two different cases, if he loses contact and if he doesn't. Whenever he loses contact, n becomes equal to 0. And that is the case that we are interested in, because that would be the minimum force that he would require from the centripetal force in order to complete the movement. That means that this equation now becomes mv squared over r is equal to mg. From here, mass and mass cancel out, and we get that the velocity is equal to the square root of gr. In a previous question, we estimated that the radius of this circle was equal to 1.6 meters, so we can calculate the velocity as equal to the square root of gravity, 9.81 meter per second squared, times the radius, 1.6 meters. We're going to get meters squared over second squared, and whenever we take the square root, the units are going to be meters per second, which gives a 3.962 meter per second measurement for the minimum speed that he needs to achieve. We need to convert this into miles per hour, and in order to do this, we're going to employ different conversion factors. 3.962 meters per second. We need to convert seconds to hours. We know that we're going to have 3,600 seconds in 1 hour. And we know that in 1 mile, we're going to have 1,609.34 meters. The result of this conversion gives us meters and meters cancel out, seconds and seconds cancel out. The units will be miles per hour, 8.863 miles per hour. So with that, it would be all. Thank you very much and have a good one.